4 candidates are there for an award and obtained distinct scores in a test. Each of the 4 cast a vote to choose the winner of the award. The candidate who gets the largest number of votes wins the award. In case of a tie in the voting process, the candidate with the highest score wins the award. Who wins the award? Alright? So see what it says. There are 4 candidates who have kind of been nominated for an award, right? Nominated for an award, and they have obtained distinct scores in a test. Distinct scores. Each of them has got a different score, right? They have obtained distinct scores in a test. Now, each of these 4 cast a vote to choose the winner of the award. So these 4 are only going to cast a vote to choose the winner. The candidate who gets the largest number of votes wins the award. So whoever gets the maximum votes will win the award. And in case there is a tie, in case of a tie in the voting process, the candidate with the higher score wins the award. So if there is any tie, we will check the score. Scores are anyway distinct, right? So who wins the award is the question. Who wins the award? Our job here is to find out who wins the award. Now, look at the first statement here. The first statement says the candidates with the top 3 scores each vote for the top scorer amongst the other 3. The candidates with the top 3 scores each vote for the top scorer amongst the other 3. So will this statement help us decide who will win the award? See, there are 4 candidates, right? Let's name the candidates are A, B, C, D. I mean, highest scorer is A, number 1. I mean, in terms of scores, number 1 is A, then we have B, then number 3 is C, and number 4 is D. So these are the 4 candidates, right? A, B, C, D. Based on their scores, they have been ranked there 1, 2, 3, 4. But are they going to get an award just based on their scores? No. The award will be given based on the votes. And if there is a tie in the voting process, then we look at their scores. So the first statement says, see, understand the question very clearly. If there is a tie in the voting process, then the candidate with the highest score will win the award. Now, what happens in statement 1? The candidates with top 3 scores. Who are the candidates with top 3 scores? A, B, and C. The candidates with the top 3 scores each vote for the top scorer amongst the other 3. Each vote for the top scorer amongst the other 3. So if you actually see, let's find out who gives vote to whom, right? I mean, you don't have to all this drama in the exam. I'm just trying to explain it in detail, right? A, of course, A cannot give vote to A, B cannot vote. I mean, one cannot vote oneself, right? What he says, the candidates with the top 3 scores. The candidates with the top 3 scores are A, B, and C. Each of them will vote the top scorer amongst the other 3. So A, who are the other 3 persons for A? B, C, and D. He will vote for the top scorer. So 1 vote will go for B. What will B do? B will vote for the top scorer amongst the other 3. Who are the other 3 for B? A, C, and D. Who's the top scorer? A. Look at C. C, the other 3 persons for C are A, B, and D. He will vote for the top scorer. A. Now, can we decide the winner from statement 1 is the question. Because the question is who wins the award. Are we capable, or are we in a position to decide who will win the award from the data given in statement 1? Is the data given in statement 1 sufficient? Well, the data given in statement 1 talks only about A, B, and C. We have no clue about what D would do. Right? D's vote will go to whom is not known to us. However, if you go by the conditions given in the question, it says that the candidate with the largest number of votes will win the award. And if there is a tie, then we will look at the high score. So far, if you observe, what is the vote count? A has got how many votes? A has got 2 votes. Yes or no? A has got 2 votes. B has got 1 vote. Right? 3 candidates have voted, of which A got 2 votes and B has got 1 vote. Now it all depends on D's vote. What will D do? There are 2 things that D can do. D will either vote for A or vote for B, or maybe vote for C also. 3 possibilities. If D votes for C, what happens? See, let's take 3 different scenarios, right? I'll use 3 different colors to explain this. Case number 1. Let's assume D votes for A. If D votes for A, automatically A is the winner because A has got 3 votes. So A becomes the winner, right? Let's take case number 2. Let's assume D votes for B. What happens if D votes for B? If D votes for B, we find that B has got 2 votes and A has got 2 votes. Yes or no? In case 2, we assume that D has voted for B. So B has got 2 votes, A has also got 2 votes. And we know that in case of a tie, when there is a tie in the voting process, now this is a tie, B and A each getting 2 votes. Who will win? The candidate with the highest score will win the award. Who is the candidate with the highest score? A. So anyway, A wins. And what's the third scenario? The third case is, let's say, where D votes for C. If D votes for C, what happens? A has got 2 votes, D has got 1 vote, and C has got 1 vote. Even in this case, the one with maximum number of votes is A. So even now, A wins. So in all the 3 cases, you'll find that A comes out to be the winner. So can I say that the winner of the award is A based on the data given in statement 1? Yes, of course we can say that. So your answer should be only 1 is sufficient as of now. Whether 2 is sufficient independently or not, we'll check it later. But the point is, 1 definitely will give you the answer. 1 alone will definitely give you the answer. Okay. I hope all of you have followed. There are 3 possibilities for the vote of D. D can vote A or B or C. If D votes for A, automatically A becomes a winner based on the maximum number of votes. When D votes for C also, A would be the winner because he's got 2 votes, which is maximum. Only when D votes for B will a tie come into picture. Because when D votes for B, B will have 2 votes as against A, who has also got 2 votes. But then as per the question, when there is a tie in the voting process, the one who has got higher score will be the winner. So A becomes the winner. So very clearly, A comes out to be the winner. Look at statement 2. The candidate with the lowest score votes for the player with the second highest score. Now, if you just look at statement 2 alone, according to statement 2, the candidate with the lowest score. Who is the candidate with the lowest score? The candidate with the lowest score is D. So D votes for the player with the second highest score. Who's the player with the second highest score? The player with the second highest score is D. So all that we know about from the statement 2 is that D's vote goes for B. D's vote goes for B. Now, if you only look at statement 2, remember, data sufficiency, you have to be very, very clear. When you're looking at statement 1, never consider the data given in the other statement. Similarly, when you're looking at statement 2, never worry about the data given in the other statement. So when I'm looking at statement 2 now, we will not keep what is given in statement 1. Right? Independently, we are verifying the statements. So statement 2 alone tells me that D's vote has gone for B. How will you decide the winner just based on 1 vote? Just imagine, there are 4 persons. I tell you that D has voted for B and tell me who is the winner. Will you be able to answer this question? No. Which means statement 2 alone cannot give us the answer. So the point is statement 1 alone gives us the answer, but statement 2 alone fails to give the answer. And hence, only 1 is sufficient is the final answer to this question. You get it? Only 1 is sufficient, the final answer to this question. When do we go for combination? When do we use the data on both the statements together? If and only if individually the statements fail to give the answer. Let's say 1 fails and 2 also fails. Then we will combine the data and see if the combination gives us the answer or not. But here, independently 1 gives the answer, 2 doesn't give the answer. So only 1 is sufficient. Option 5 is the final answer to this question.